Hey STEAM team, glad you're back to feed your brain with some more chemical reactions. Today we're going to be doing kind of a weird chemical reaction, or there's going to be a few chemical reactions taking place. I call this one socially distancing hydrogen and oxygen. Okay, and that's because we're actually going to take water, typically a product or part of a product for us, and we're going to split it into its atomic parts. Okay, we're going to break it up into hydrogen gas and oxygen gas using a little help from a battery, the energy from our battery. Let's start by taking a look at our chemical equation. Notice our reactants. We have 2 molecules of water, and when we add a little energy, we are going to get 2 molecules of hydrogen gas and 1 molecule of oxygen gas as our products. A hydrogen atom, when we reduce it, it's going to gain electrons. When we have our oxygen oxidizing, it's actually going to lose an electron. So hydrogen is going to gain electrons, right? Positive attracts negative. And oxygen is going to try to push away electrons, right? So that negative is going to push away the also negative subatomic particle. It's important to think about charges here because we actually have 2 different opposing charges on our 9-volt battery. We have one side, which is positive, that is our anode, and then we have the opposite side, the cathode, which is negative. Okay, so the positive side is going to attract the negatively charged particles, and the negative side is going to attract the positively charged particles. The opposite, our anode, is going to pull in those negatively charged particles, and our cathode is going to push away the negatively charged particles, right? Negative repels negative. Okay, that was a lot on stuff we can't see, all of those subatomic particles. So we're going to get back to the experiment. And I just wanted to take a moment to talk about, but how? I asked you guys, how was I going to be able to use those 7 everyday objects to create this chemical reaction? Lots of you guys crushed the prediction. Nice job. A lot of you knew that electrical energy from the battery was going to help us force those atoms apart, and that was awesome. Those of you that agreed with your classmates, that was cool, although I don't remember the directions involving reading your classmates' predictions. I do remember asking you to make a prediction based on what you thought. So don't forget, think for yourselves, guys. I want to know what you think, okay? I'm hearing what everyone else thinks already. Some of you made the brilliant prediction, this made my heart flutter, I was so excited, that the salt, the NaCl, was going to increase the conductivity of the water. And that was amazing. You guys are geniuses. And that's absolutely correct. So let's look at the demo. Okay, now that I've added our graphite conduits to our 9-volt battery, remember, our 2 reactants are water and energy. Our products are going to be hydrogen gas and oxygen gas. Maybe something else too. Okay, but I just wanted to show you that I haven't added any NaCl, any salt, to our water yet. So our water is still currently a very poor conductor of electricity. Notice there are no bubbles coming from either conduit, right? Remember, we have a cathode side and an anode side. The anode side is going to be our positive side, and the cathode side is going to be our negative side. Okay, so I'm going to add our NaCl. Okay, just a little common table salt. We're going to give it a little swish, and you'll see right away the conductivity of that water is going to change. Okay, so as that NaCl dissolves, changing the physical makeup of our water, right? Because we're making a solution now, a mixture of NaCl and H2O. We're going to start to see that chemical reaction take place, okay? And we're going to know what's happening because there's going to be bubbles either hydrogen gas or oxygen gas escaping from either end. Okay, so I'm gonna put this somewhere to film a time lapse as it gets going, and you guys can check that out next. Observe the bubbles traveling towards our positive anode side of our battery. Those are our negatively charged oxygen molecules, okay? And they're traveling in the form of a gas here. They can't resist that positive charge pulling its negative charge towards it. Okay, now check out the negative side, our cathode on the right. And notice that there is so much repelling. So that side is actually pushing the negative oxygen molecules out. So you should be seeing oxygen gas exiting that cathode side. If oxygen gas is being released on our negative cathode side, look at those bubbles, we know that hydrogen gas is being released on the anode side. Remember, hydrogen is positively charged, so it's going to be attracted to that negative cathode side, and it's going to be repelled by that positive anode side. Okay, let's wrap it up. By adding NaCl to our water, we increased the conductivity so that electrons could flow. That electrical energy from our 9-volt battery was able to travel down to our solution using our graphite conduits, and we were able to witness hydrogen and oxygen molecules being split apart and expelled either from the anode or the cathode. Okay, guys, it's time for your STEAM Team Challenge. You are going to choose one of the following questions and explain in a quick blog or podcast. Post that to Google Classroom or tag me and hashtag the STEAM Team on Gram or TikTok. Okay, number 1, remember when we added NaCl to our water to increase conductivity, which of those atoms, sodium or chloride, would be attracted to the anode? Why do you think that? 2, pretend we know there are 90 water molecules in our glass of water. After the chemical reactions, how many hydrogen molecules would we have? How many oxygen molecules would we have? Revisit the formula at the beginning of the video for clues. Okay, 3, which side of the battery, anode or cathode, has more bubbles being pushed out? Why would one side have more gas molecules escaping? Think about the formula. Okay, feel free to take a screenshot here to help you remember the question. And I think your brains are full. So happy Friday. And I can't wait to see your vlogs. I miss you all. Make sure you're washing those hands.